Okay, so I just dove into this monad consensus client thing, and it really shifts how I see blockchain architectures.
Seriously, what about it caught your eye? I've seen a few layers here, but nothing too surprising.
It's the way it combines the consensus client, execution client, and a JSON RPC server. Like they all work in tandem, mind-blowing.
Right, the integration is neat. But isn't that just the norm now with blockchain architecture? What sets it apart?
Well, wait, this design makes the execution happen in real time with a state mutation. That's pretty advanced, don't you think?
Real-time updates are compelling, but I wonder, does it hold up under heavy load? What about scalability?
That's a good point. It might not handle huge volumes gracefully. How does the TriDB come into play here?
The TriDB is crucial. It stores block information and updates the blockchain state, which simplifies data retrieval.
Exactly, it's like having a dedicated librarian for your blockchain, but does it introduce any bottlenecks?
Potentially, there's always that risk with central data points, but the overall structure seems robust, at least on paper.
And I love that you can use Docker to manage it easily. That's like the cherry on top.
For sure, but Docker's not always seamless. Have you considered how that might affect deployment?
Great call. I mean, it could complicate things if dependencies are not handled well, might lead to version conflicts.
Totally. Also, while we're at it, how do you feel about the JSON RPC server? What's the role there?
It's the bridge for communication with the blockchain, so it's kind of essential, right? But can it handle high traffic?
Exactly, but keep in mind high traffic could lead to throttling issues. Have they addressed this anywhere?
Not explicitly in what I saw. Maybe that's a gap we should keep an eye on.
Definitely. This kind of system works well, but it feels a bit like painting with broad strokes, don't you think?
Yeah, it's impressive, yet I feel like it glosses over specific internal mechanics. It's almost too simplified.
Right, and simplistic approaches can lead to unforeseen consequences, like security vulnerabilities.
Speaking of security, has there been anything mentioned about protocols in place for data integrity?
Not much. It's crucial to understand how they ensure data is tamper-proof next to swift processing.
Exactly, imagine a flaw where a malicious actor manipulates block data. That could be catastrophic.
Totally. This highlights the balance between speed and reliability that can often be challenging in tech.
It's fascinating how intricate this all gets, so what's the overall takeaway here?
Well, it's innovative but requires cautious skepticism. The potential is vast, yet it's not without cracks.
So it's like a double-edged sword, exciting with risks lurking around the corner.
Precisely. We need to keep evaluating as more concrete implementations emerge.
And that's the real journey, isn't it? Discovering how it holds up in the hands of actual users.
Exactly. Plus, each new layer introduces its own complexities. This will keep us on our toes.
Totally, can you imagine years from now? We could look back at this era as pivotal in blockchain evolution.
Definitely. But it's also worth questioning if these systems will stand the test of time or cause upheaval.
Right? Makes me think if future iterations will prioritize stability over just trying to be first to market.
And that's a crucial conversation to be had. Balancing speed and reliability could redefine success here.
Absolutely, I'm excited to see what unfolds. But for now, are we leaving it at that or digging deeper?
I think we've set a solid stage, but let's keep exploring this topic in future episodes.
Agreed, so many questions and thoughts to unravel as this tech evolves.
Totally. Let's keep the curiosity alive and revisit as things continue to develop.